All right, so this is our second video with page number 51. We're on question number 14, I believe. Right, so we're on question number 14. Let's just make my point just a little bit smaller, I think, here. That is fair. Okay, so according to reference table G, so I'm going to have to go to table G. What is the difference between the amounts of KClO3 and KNO3 soluble in 100 grams of water at 40 degrees? So I need to go to table G. And at 40 degrees, I'm going to compare the amount that can be dissolved between these substances. So KClO3 and KNO3. So going to table G. Okay, and I'm going to be looking at what temperature? 40 degrees, KClO3, so 40 degrees is right here. And I'm looking at KClO3, which is this line right here. So at 40 degrees, that's this point right there. And KNO3, which is this line right over here. And so I'm going to find that one at 40 degrees. Where's that point at 40 degrees? So that is right here. And let me just make the screen a bit bigger for you guys to see here. And all right, so now those are my 2 points at 40 degrees. So I have about 15, let's say that's about 15, and that's about 65. So I would just do 15 minus 65, and right, so 15 minus 65. So going back to our questions. So 15, so it's not going to be 64, and it's not going to be that. So I'm going to do my 65 minus 15, right, comes out to be about 50, and that's going to be our closest. Remember, with table G, you really have like a plus or minus 2 because of the way that that you can read the graph. All right, so question 15. As the temperature goes from 0 to 25 degrees, the amount of NH3 that can be dissolved in 100 grams of water. So going back to my reference tables, between 0 and 25, and I'm looking at ammonia. So between 0 and 25, between 0 and about 25, which would be right about here, I want to see what happens to my concentration of ammonia. So my concentration of ammonia starts over here at 90, and to 25, it goes to about here. So concentration is going down, right? So concentration is going to decrease. So going back to my table. So concentration is going to decrease, not increase. And of course, I need to figure out by how many grams from 0 to 25. I should not have erased those spots. From 0 to 25. So 0 was where? Right here. So from 90 to 25 is about here. So 90 minus 50. And going back to our, so 90 minus 50 is going to be 40 grams. All right, so number 16. According to reference table G, a temperature change from 10 to 30 degrees would have the least effect of solubility on. So it means it's going to be a flatter line, not a steep line, right? So that would mean, so let's go from 10 to 30, and we're gonna look at sodium chloride and potassium chloride, right? So, well, because those were choices A and B, right? Or choices 1 and 2. Oh, sorry. So sodium chloride, potassium chlorate, ammonia. Okay, so let's just going back here. So I'm going to take a look at, trying to remember all of the substances I think we had here, right? So we had this one, this one, this one, and what was the third one? So those are the 3 substances that we need to look at, or 4 substances, and from 10 to 30 degrees. So from 10 to 30 degrees, I want to know which one has the temperature has the least effect, okay? So then now if I'm looking at SO2, because that's the first one here, right? I'm going from here to here, right? So that's just about 10. Now if I'm looking at here at the KClO3, right, I'm going from here, which is 5 to just a little bit above 10, you know, so that's like at about 5, right? Oh, now that's actually about 10 too. Well, let's say 6 or 7. All right, so we'll look at that. Now, if I'm going to my next line, which is my NH3 here, right? So I've got a pretty steep line down here. So no, that one's definitely not going to be it. And now if I look at my sodium chloride starts here and here. So there's really not much change. So sodium chloride is going to be our answer for that one, choice number 1. So which salt has the greatest change in solubility between 30 and 50? So now I'm looking for the greatest. I want the steepest change. And we have potassium nitrate, potassium chloride, sodium nitrate, and sodium chloride. Well, it's not going to be sodium chloride, right? We just looked at that one. And let's find KCl. So let's just take a look at what our other ones are here. Right, so we're looking at potassium chloride is here. And we're looking between 30 and 50 degrees. So between 30 and 50 degrees. Potassium chloride, KNO3, which is this one right up here, right? And sodium nitrate, that one, and sodium chloride, which we decided it wasn't going to be it. All right, so, and I'm looking between 30 and 50. So between 30 and 50, I go from here to about here. That's not really that steep. Now, if I'm taking a look at this line right here from 30 to 50, I'm going to go from here at 30 to 50. I'm going to go to here. All right, so that's, let's say that's like 5, 15, 25, 35, a little bit more than 35. So that looks like it's a pretty good possibility, our potassium nitrate. And if we're going to go from here to here, that's going to be, so this is going to be, it looks like it's going to be our steepest line right there, potassium nitrate. So choice number 1. All right, let's go on to our next page. So students tested the solubility of a salt at different temperatures and then used reference table G to identify the salt. The student's lab table is below. What is the identity of the salt? Okay, so now this is per 10 grams of water. All right, so now our reference table G is 100 grams of water. Right, so then that's a factor of 10. So if I multiply this by 10, that should be pretty good. So which one can I get about 120 grams at 30 degrees Celsius? All right, or can I get at 62 degrees Celsius, which one am I going to get 30 grams at 62? Oh, sorry, that would be 12, not 120, sorry. Moving the decimal place 1 place over, not 2 places over. So let's find 50 degrees and let's see if we can find something that has 22 grams dissolved, right? So 50 degrees and 22. Okay, so let's go to 50 degrees and 22. And oh, there's 50 degrees and about 22. And what line is that? KClO3. So then that looks like about right? So potassium KClO3. And that is potassium chlorate. So now let's see if at 30 degrees, am I going to have 12 grams, right? So at 30 degrees, do I have about 12 grams? Yep, so that confirms that my answer. Awesome. Okay, and now let's go on to number 19. So student determines the mass in grams of compound X that would saturate 30 grams of water over a temperature range of 40 degrees and 10-degree intervals. Here's our results. If the solubility trend continues, what is the total number of grams that will dissolve in 30 grams of water at 60 degrees? So basically, I need to figure out what is it going to be at 60 degrees. So now I go 2, 4, 8, 16, 32. So 2 double is 4, double is 8, double is 16, double. So I would basically be doubling 32, right? So 32 times 2, right, would be 64. All right, so we have question number 20. And hold on, I gotta make this a little bit smaller here. Or I actually need to move this up. I'm gonna move that up over here. Because when I'm working towards the bottom of the screen, I gotta move some stuff out of the way here. Okay. We have 100 grams of water is saturated with ammonium chloride at 50 degrees. According to table G, if the temperature is lowered to 10 degrees, what is the total amount that will precipitate? So I need to find these 2 points, and then I need to subtract the 2 to figure out how much will come out of solution. So let's go over to table G, and I should have never moved this because now that's going to be, so table G, and we're looking at ammonium chloride 50 degrees to 10 degrees. So we're looking at ammonium chloride 50 degrees to 10 degrees. So here is my ammonium chloride. 34. So here is my 50 degrees. And I wanted to go down to 10 degrees, which is here. Right, so I'm at 35 and let's say 52, right? So 52 and minus 35, does that sound about right? So that's about 17. So it's going to be about 17. And there we go, 17. All right, so how many grams of potassium chloride must be dissolved in 200 grams of water? All right, so this is double the amount of water than table G. So it means I have to multiply by 2 to make a saturated solution at 60 degrees. So I need to find the point that intersects KCl with 60 degrees and then find out how many grams and then multiply by 2. All right, so 60 degrees and then KCl. And let me just move this up here. So I have, KCl. Sorry, I have like short-term memory loss here. 60 degrees KCl. All right, so 60 degrees and potassium chloride is right here. Okay. So that is, it's just about 45. And that's in 100 grams of water. So then if I multiply that by 2, I should get about 90 grams. There we go. And I really just, actually I'm just gonna hide this control. So then, where is this? Hide floating meeting controls, there we go. Don't know why I didn't think of that before. All right, so we have a solution contains 14 grams of potassium chloride and 100 grams of water at 40 degrees. What is the minimum amount of KCl that must be added to make this saturated? So I'm gonna go 40 degrees and 14 grams, and then I need to see how much more do I have to go up to that line. So 40 degrees and 14 grams. So 40 degrees is here, and 14 grams is just about here, right? And so now how much more do I have to make it saturated? So that means I need to go from here up to the KCl saturated line, which is here, right? So that means I need to go up, it's not quite 40, so let's just say it's like 38. And I needed 14 grams. If I subtract the 2, that's how much I need to go up to here. And so I should have to add about 24 grams. And there's my answer, 25, right? Because this is that's about. Remember, you got this whole plus or minus 2 on reference table G. All right, continuing on, we're getting there. So now which is a saturated solution? So I need to figure out which one of these has the point on the line on table G. And the only way to do this is to just go through each and every single one of them. So now 40 grams and 40 grams and 50 degrees is NH4Cl. So 40 and 50, 40 grams and 50 degrees Celsius. Right, so 50 degrees Celsius and 40 grams is not saturated for, which one are we on here? Let me just take a look over here. NH4Cl. Nope, it's saturated for NaCl, so that's not the right answer. The next one is 2 grams of SO3 at 10 degrees. So at 10 degrees, 2 grams is not saturated for sulfur dioxide, so it's not choice number 2. Choice number 3 says 52 grams of KCl at 80 degrees Celsius. So I go 80 degrees Celsius and I go to 52, and that's right here. And that is saturated if it's KCl, potassium chloride. Answer 3, yes, it's on the line, it's saturated. So my answer is choice number 3. If I was going to check choice number 4, my answer would not be saturated. It would either be below the line for potassium iodide or above. A solution containing 90 grams of potassium nitrate in 100 grams of water at 50 degrees Celsius is considered. All right, I have saturated and unsaturated, dilute and concentrated. I need to find the point on this line. Okay, so I need to find 90 grams and 50 degrees. So 50 degrees and 90 grams is right here, okay? And now my question is asking about KNO3. So where is the KNO3 line? Because now I need to make this, gotta make this best fit. So 50 degrees and 90 grams, and here is KNO3 that is above the line, right? Do we agree? My point is above the line, 50 degrees and 90 grams. I want to make sure that I'm reading the question right. So 90 grams and 50 degrees. Yep, and that's above the line. So then if it's above the line, so I'm just going to write here, that's above the line. So that means it is super saturated, right? So super saturated. And if it's super saturated, it has to be concentrated, because that's what that means. Dilute means weak, not a lot dissolved. Concentrated means strong, lots dissolved. All right, number 25. I know these ones take a long time because of having to go back and forth with the reference tables. A solution is formed by dissolving 45 grams of ammonium chloride in 100 grams of water at 70 degrees Celsius. Which statement describes this solution? So I need to find 70 degrees, 45 grams. Okay, so 70 degrees and 45 grams. And 70 degrees, all right, so 70 degrees and 45 grams is right about here, right? 70 degrees, 45 grams, and 45 grams NH4Cl, and that is below the ammonium chloride line, right? Because that's my ammonium chloride line. My point is below the line, so it's unsaturated. So NH4Cl is the solute, that is true. Get rid of those. And the solution is below the line, so it is unsaturated. All right, so which quantity of salt will form a saturated solution at 45 degrees? Okay, so I need to find 45 degrees and see which one of these combinations of grams and temperatures is going to give me a point on a line. Only thing to do is just to go through each one. So I need to do 45 degrees and 30 grams and see if it's on the line for KCl. All right, so I have Again, so tedious. Okay, so 45 degrees is here, okay? And I have 30 grams of KCl. So that is here. Oops, that's right here. And that's not saturated because it's below the KCl line, potassium chloride line. So now if I go to 35 grams, right? Now I'm just gonna put that right about here, right, at 45 degrees. And NH4Cl, right? So that is below the NH4Cl line, which is here, so that's unsaturated. Now let's go to 60 grams, which is here at 45 degrees, right? And that's our point right there. And is that saturated for KNO3? So this is the KNO3 line right here. This is the KNO3 line right there. So that's unsaturated. Now 110 grams, now we're gonna have to go up to 110 grams right here. 110 grams. Wow, this doesn't seem to really want to work out for me, does it? Oh, let's see here. Let me go to, do I want to fit to height or fit to width? Oh, let's see, fit to height. And no. Okay. So if I have 110 grams at 45 degrees and 110 grams, there we go. That's that point right there. That at sodium nitrate is on the line. I was getting a little bit worried going through all of those. Okay, obviously it's much easier to see when it's not on a computer, when you can actually just look at your paper reference tables. It goes a lot faster than this does with me explaining it anyway. But hopefully you're sticking with me. Okay, so based on reference table G, when 100 grams of water is saturated with KNO3 at 70 degrees, and then it is cooled to 25 degrees, we need to figure out how much is precipitated. That means falls out. So I need to find the 2 points and I need to subtract them, right? So I need to go with, I need to find a saturated solution of KNO3, okay? And so I'm going to do that at 70 degrees. So at 70 degrees, so at 70 degrees, where's my cursor here? Oops, at 70 degrees, and a saturated solution of potassium nitrate at 70 degrees is about here. Okay, so that's about, let's say 135. And we're gonna cool this solution down from 70 degrees to 25 degrees. So we need to cool this solution down, and then we're looking at potassium nitrate, if I am correct here. Yep, potassium nitrate. We're cooling down, so I need to cool down, 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 and I'm gonna find down to all the way down to 25, which is right about here. Okay, and how much is going to precipitate out? So let's say that is probably like about 43. All right, so let's say about 43. 10, so probably like anywhere around 92 grams. So we're gonna go with the 95. Right, so which solution would be the most dilute at 0 degrees? So the most dilute would have the lowest amount dissolved at 0 degrees. So we're going to be looking at the lowest line on the reference table at 0 degrees. Okay, so going back to 0 degrees. So potassium iodide, that's not going to be dilute because look at how much we can dissolve in there. So that's not going to be our answer. If we go to sodium chloride at 0 degrees, that's this line right here. Sodium nitrate is way up here, so still looking here at sodium chloride being the lowest. And then now we have KClO3, which is right here. And if we follow this line all the way down to my 0 degrees, all the way down here, that's my lowest line. So then that's going to be my answer. All right, last question. A solution contains 130 grams of potassium nitrate dissolved in 100 grams of water. When 3 more grams of potassium nitrate is added, none of it dissolves, nor do any additional crystals appear. The temperature of the solution is closest to. Okay, so if we have 130 grams, doesn't give a temperature, does it? 100 grams of water, 3 more grams is added, none dissolves. Oh, we have to find the temperature, that's why. None dissolves, nor do any crystals appear. Okay, so if nothing else dissolves, but nothing else appears, that means it's going to be saturated. So then I need to find the saturation point where I can get 130 grams of potassium nitrate in there. Okay, so 130 grams is right up here. And then I'm going to read across to my potassium nitrate, which is here. And then now I'm going to read down until I can get that right temperature, 70 degrees. And so that's going to be 70 degrees. Okay, and there you have it. That is our solubility curve questions. Thank you for joining me, and I hope you're patient. All right, and until our next video.